All right, so the next thing we want to do, okay, so we've done this math stuff, we've looked over Appendix C and the key stuff in there. Now I want to summarize and kind of hit some of the highlights of Chapter 1. Chapter 1 kind of talks about the big picture of astronomy, so that's what's going on here. So Chapter 1, the big picture. In a way, this is kind of a summary of kind of the highlights. This is the highlights reel of what we're going to be seeing as we study the rest of the course. So all the details and the evidence and the logic and the theory and all the work behind these amazing discoveries isn't in Chapter 1. That's scattered throughout the whole rest of the book. But the general perspective is it kind of gives us this idea of how we can understand where we are in terms of our place in the universe, in terms of space, in terms of time, in terms of motion. These are all fascinating and interesting things. So let's talk about this. Where are we? So where are we in space? Astronomy allows us to get some perspective on this. Where we are, how much else is out there, what is our place within things. First of all, we're on our lovely planet known as Earth, which we all know and love. So where is the Earth? The Earth is in our solar system. The next big step out from the Earth is our solar system. And let's be very clear what this means. Okay, sometimes people get these solar system, galaxy, universe, these terms can be confusing. Our solar system contains one star. We call it the sun. And all the stuff that orbits around it. And all that orbits it. All that orbits it, meaning the sun. So what do we have? Well, we have 8 planets. Yes, Pluto was demoted. 8 planets. We have their moons. We have comets. We have asteroids, we have the rings around the planets. Everything that orbits around our sun is our solar system. That's what it is. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto's still out there. It's still part of our solar system since it orbits the sun, even though it's not a planet. And so that's what our solar system is. And as I think about our solar system on the biggest scale, the one thing you want to know about our solar system is it's basically, mostly, overwhelmingly, the sun. If you were to take the sun and put it on one side of the scale, and then all the planets on the other side of the scale, even the big ones, Jupiter, Saturn, Uranus, Neptune, the Earth, all the planets, all their moons, all the comets and asteroids, everything that orbits the sun, put that over here and compare that to the sun's mass is way more. As a matter of fact, our sun has a mass about 1,000 times more than everything else in our entire solar system. So if you were to add up everything else on all the planets, put them all together in one big lump, our sun has a mass 1,000 times more. Our sun is 99.9% of everything in the solar system. So our solar system is dominated by the sun. The planets in that are just leftover crumbs when you make the sandwich of the sun. So that's what our solar system is. The next big step out beyond our solar system is our galaxy. Galaxy, which we call the Milky Way. I need a little more space on that. So let's talk about our Milky Way galaxy. Our Milky Way galaxy has lots of suns in it. Our Milky Way galaxy has hundreds of billions of suns, hundreds of billions of stars. So the Milky Way, it's not just a candy bar, it contains hundreds of billions of stars, meaning suns. Each one of those stars probably has its own solar system of planets and things around it. So that's our Milky Way galaxy. It contains hundreds of billions of stars, hundreds of billions of suns, and then they all are held together. They orbit around in this disk shape. They all orbit around by gravity. Our sun orbits the center of our Milky Way galaxy about once every 200 million years. So 200 million years ago, our solar system was at this point in its orbit. Let's see, 200 million years ago, that's when dinosaurs ruled the Earth, and they were new. So this is how long it takes our sun to orbit our Milky Way galaxy. What's beyond the Milky Way? Are there other galaxies out there? Yes, as discovered by the great American astronomer Edwin Hubble in the 1920s. There are other galaxies out there. So that's the next step out. Other galaxies. And how many other galaxies out there right now with the mighty Hubble Space Telescope, the most wonderful instrument ever created by human hands? We can look for all these galaxies in a tiny patch of the sky and then multiply that over the sky, figure out how many galaxies are out there. There are hundreds of billions of galaxies visible. Right now, currently, with present-day technology, with the mighty Hubble Space Telescope, we can see hundreds of billions of other galaxies out there. And wow, good grief. So the total number of stars, we can see the stars in all those galaxies, each galaxy containing several hundred billion suns. Multiply that out. Several hundred billion stars per galaxy times several hundred billion galaxies visible. That is a number that's enormous. That's on the order of 10 to the 23. That number is far, far larger than the number of grains of sand on every beach on the face of the earth. And that is our universe. So our universe is everything. All those hundreds of billions of other galaxies out there. Our universe is all that exists everywhere. Our universe is vast, it is immense, it is enormous, and this is just what we can see now. I mean, the Hubble's 20 years old. Give us the next generation of telescopes, we will see more. So this is just a lower limit on what's out there. Okay, so those are key concepts. I want you to be very clear about the definition of the word solar system, or words, solar system, galaxy, and universe. Let's not get those confused. All right, so that's kind of our view in space. How about time? The big picture in terms of time, I guess the first thing I want to say is there's some really amazing things. We'll talk about all the evidence behind that later on in the course. But for right now, there's some amazing discoveries. For instance, our universe had a beginning. You may have heard of it. It's called the Big Bang. This Big Bang event took place 14 billion years ago. 14 billion years ago. A long, long time ago, but not infinitely far around. Our universe has not always been around. There is a time when time itself began. There's a point before our universe came into existence. Our universe began 14 billion years ago with this amazing Big Bang event. And the Big Bang filled all of space everywhere. It's not some ordinary explosion where it happens here and goes out into empty space. No, the Big Bang filled every point in space everywhere equally. There was no point in the universe which was not filled with the Big Bang. And it filled the universe with hydrogen and helium gas and some tiny traces of lithium and beryllium, and basically that was it. So after the Big Bang, our universe didn't have any of this carbon and nitrogen and oxygen and stuff like this. That's 14 billion years ago. About 13 billion years ago, we have the first galaxies and stars forming. Galaxies and stars. So the first stars. How do stars work? Well, gravity pulls together all this gas. By gravity's pressure, it causes nuclear fusion reactions to take place at the center of these stars, squishing hydrogen and helium atoms together to make heavier atoms. And that's where stars get their energy. And so then they shine and they take this hydrogen and helium and they do fusion and they turn it into other things. They turn it into carbon and nitrogen and oxygen and iron and calcium and all these other elements that things are made of. These first stars shined out into the universe, created other elements, and then they exploded. They spread their guts out into the universe, where all this gas then cooled off. Gravity pulled it together and formed another generation of stars. There were about 2 generations of stars before our solar system formed. Our solar system, the Sun, the Earth, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, our whole solar system formed together. All these objects formed together at one time in one event about 4.6 billion years ago. Our solar system formed about 4.6 billion years ago. So this is interesting. So that means the oxygen in my lungs, the carbon that holds my DNA together, the calcium in my bones, the iron that makes my blood red, these were not created by the Big Bang. That made only these light gases. No, these were created by these ancient stars, these 2 generations of stars which existed before our solar system formed. And so these stars shined and then exploded, and their material is what we're made of. So that's why in the book they do that quote from Carl Sagan. They say, we are star stuff. We are made from the remains, the debris of ancient stars which shined and exploded long, long ago. And then our solar system, the Earth, formed about 4.6 billion years ago. And so things have gone on from then. So I guess the book does kind of a calendar to give you a sense of this. 4.6 billion years ago, that's about roughly, about a third the age of the universe. 4.5 is 50, it's about a third the age of the universe. So for about 2/3 of the universe, there was no Earth, and then for about the last third of the universe, our Earth has existed, and then it's into geology and paleontology and things like that. First life formed on Earth about 4 billion years ago. Life came out on land about 500 million years ago, 500 million years ago. Human beings, fully modern people, have been around for, well, anatomically at least, for the last 100,000 years. Human civilization fits in the last 5,000 years or so. And so that gives us a sense of where we are in terms of space, in terms of time. And I guess the last big picture thing I want to do is in terms of motion. Motion, here we go. In terms of motion, things are moving, and astronomy tells us where we are in the scale, in all the scale of all this motion. First of all, the Earth spins. Probably heard this before. It spins once every day. Every 24 hours, so the Earth is going around, and the Earth is going around, and the Moon orbits the Earth, makes a big circle around the Earth roughly once every month, and then once every year the Earth makes a big circle around the Sun. Earth orbits the Sun every year. And then, okay, so the Earth is spinning and the Moon's moving around the Earth, and the Earth is spinning and the Moon is orbiting as it moves around the Sun. And then we've got the Sun orbiting in this great big giant orbit around our galaxy. Sun orbits our Milky Way galaxy. And we said that takes about 200 million years, a very long time. And there's a little bit of motion of our local group of galaxies, but then the big motion beyond that is the expansion of the universe. And by the expansion of the universe, what we mean is that distant groups of galaxies are moving away from each other. It's like space itself is stretching out between groups of galaxies. Galaxies are getting farther away from each other. Farther away from each other. I am not expanding. The Earth is not expanding. The solar system is not expanding. The galaxy is not expanding. What's expanding is the distances between galaxies, and that's stretching out over time, and that's the leftover momentum of the Big Bang itself that continues. The discovery of the expansion of the universe by, again, the American astronomer Edwin Hubble back in the 1920s is kind of the first piece of evidence which led us to this Big Bang idea that there must have been some beginning to cause this stretching of the universe to get started. So there we go. There's a very quick outline of, this was chapter 1. Please read this very carefully. I'm assuming you're reading this as well, and I'm putting out some of the highlights here. And so thank you very much for your attention. Again, if you have any questions about anything, any difficulty with the homework, please get in touch. Give me a phone call, send me an email, post something on there, and we'll help you out. Good luck, and thank you.